So hello everyone, today again we're solving another Advent of Code challenge, and again we're doing this in the programming language NIM. We are learning NIM as we're solving these problems. And today's problem is rope bridge. It had a long explanation what this is about. Elves, you are going over a rope bridge and stuff is happening, and it's kind of a wonky story. I won't go through that story. Let's just have a look at the problem and let's get coding. All right, and what do we have here? So we have a grid of some sort. We can think of a matrix as in the drawing board already have, and we have a rope, and the rope has a head and a tail. And let's say that we start with the head being here and the tail being there. And the thing is that the head and the tail always have to touch each other, either like left or right, but it can also be like diagonally, so this would also be acceptable. And then we're given like an instruction set for how the head moves, for example. So the head moves, for example, if it goes one up, then now our tail needs to react and it has to go back where the head is. If the head moves here, that's okay because we are still like in this diagonal fashion close to the head. But now if the head goes again there, now we have to do a diagonal move. And this is actually explained here as well, how the diagonal moves are made. So we go like diagonal there, and now we're again close to the head. Okay, and the question is obviously then that if we are given, so like the input to our puzzle is this basically. So the instructions for how the head should move. And now the question is, how many positions does the tail of the rope visit at least once? So in this example case that we have, it's 13. So these all these like places marked with a hashtag are places where the tail has been at least once. So this is what we're going to solve. So we're going to need matrices again. So I'm going to reuse the matrix type that we used previously. So if you want to know more about that, please go watch yesterday's video. If not, I think you'll be able to just fine hang along. All right, so let's code. So since we're going to use the same matrix data type that we used previously, I've now made a matrix.nim file, which is in the same directory as this AOC 09 file. And as you can see, if we just import matrix and try to initialize new matrix, we're getting this squiggle line undeclared identifier. But if we do this trick, it goes away. So in NIM, if you put this star after things, the things will actually get exported. And for this, you have to do it for all the keys that you want, and all the functions as well. So now we're just iterating, and then we're saying like m dot data dot add, and then we want to add the default value that we're pushing into this, and then this obviously as well should be exported. So I think this is going to be our small matrix library that we make for this project. Let's continue like that. So there we have our empty grid, and then we can just do like maybe we should do, let's say that grid dot change, and then at 1 and 1 there we put the head like that. So there we have our head at index position 1 1. So now we want to have a smart way of moving our head in the matrix. And we're only gonna move in like one direction at a time. So let's actually also do like a type for this. It's gonna be called move enum, and it's gonna have up, down, left and right. It's gonna be the things that you will be able to move. Plus, because right we are going we're going to the right. It's not always easy. It's not always easy. And then we can say m dot change the new x and new y2. It's going to be a joint m, and then result is going to be new x and new y, like that. So I think that's our move head function. So in nim you always have to discard the value if you're not going to do anything with it. So now we can print these. Let's see, we are first here and then we are here. Is that what we even wanted? We wanted to go up, not down. So these are the wrong way around. R minus and R plus, like that. So now we're here and we're giving the command to go up one. So we get that. Beautiful. I didn't want to bore you with reading in another file, but we are doing something nice here. We're creating a new object type, which is called instruction, and it's going to have move, which is a move, and it's going to have an amount, which is an integer, and all the squiggly lines went away. So this is the way we're parsing it, and now we're getting in the instructions here. So now we can, in our main module, we can say let instructions. Oh my god, I'm just gonna say it's called inst, and that's the what was called read instructions was the function. So now we have that. So now we can do for int. No, we can't do that. For inst. So are we now able to do? Yeah. So now you can see the head is moving around in the matrix. Dun, 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 dun. This is like a funny animation going on. So, and the next thing we're gonna need is as well a way to move the tail. And first of all, we can do. I've copied like similar thing, but now we need to also do a check. If we are close to the head, then we don't need to move at all. So let's have actually sort of like a var should move, and then it is true, something like that. And then we say that now we have both the x head minus, we can do x head minus, yeah, x tail, and this should be the absolute value because we don't want to deal with negative values. So if the difference between them is larger than 1, so let's actually set this to false, and then we can do the same operation, but we just do it for y and y. So if this, yeah, so now if this is true, then should move becomes true. I thought about this move logic actually for quite some time, and I've actually come to the conclusion that this doesn't have to be that fancy at all. Actually, I think we can get away with such a hack that in here we pass the previous position of the head, and that should always be where the tail should go. Like for example, if we look at this, it's always in the previous one. Even when we do like a diagonal, the head is here, the tail is there, the head goes up 1. So I'm thinking we don't need any fancy logic of like checking where it is, and like, I don't know, I was thinking first about some like Euclidean distances or whatnot stuff. So now when I do, yes, all the squiggly lines went away, and now our animation should, okay, so the tail is definitely moving to places, but why is not our head moving places? The tail and the head are constantly at the same position, even though should move is false. So that's, I don't really, oh, this is definitely wrong. This should be, yeah, okay, that's first of all, and this as well. Okay, so this is because we just copy pasted stuff. Yeah, okay, if we go now. Okay, now they're not at the... Yeah, okay, yeah. Yeah, this says like that. But hey, yeah, now it's tracking it. And hey, did you see the diagonal? It went correct. Let's see. Okay, now there's a diagonal. Now the tail should go where the head is now. It should just like diagonally move up. And let's see. And it does. Oh, that's really nice. So lastly, we need a score grid. So score is a new matrix of type int. And then we also should initialize that score.init, the same width and the same height, and they are all going to be zeros. And then here we should have a score.update score function, and we should pass in the current position of the tail, and let's implement that score every time we move this thing. So now we can see that the tail is actually, let me make this a bit bigger. So the tail is there, and we see like that's one. Okay, we see it's populating this. So that one remained 2 because it was there 2 times. That won't make any difference for our analysis. But yeah, it seems to be working. Score.data. And now we're kind of speed running this, and we get 13, and that should be actually what we expect from this. They said 13 positions, so we're just So, and as you can see in the real input data, these numbers are a bit larger than in our test data. So there's no guarantee that this is going to be large enough for us to be able to traverse around it. So what I'm gonna do, instead of making it dynamic, so that if we go to like an edge, then we just like add 1 row or we add 1 column, I'm just gonna make it super large. We're gonna initialize ourselves in the middle, and then we hope that we don't run out of bounds. And if we do, let's just make it larger, and it shouldn't in principle make any difference, just that this is like super inefficient. That's the only problem. But I just don't want to deal with the logic of actually, oh now, and I shouldn't be printing this out now. Okay, so it finished. It says 6,266. Nice. Very, very nice. On to part 2. So now we are working with part B, and those of you who pay a lot of attention to details, you might notice it is not anymore Friday the 9th. Now it's Sunday the 11th, so I'm way behind of schedule with this. But hey, let's boost them through today. And yeah, let's just wrap it up, the part B, make it done. And then I have 2 more to finish today. Hopefully I'll be able to make it. It's after all Sunday. So yeah, to make this a bit faster, I already have the solution basically here. I think I have the solution. So now what we should do, instead of just having 1 tail, we have now several. So basically here's the head again, and then you can see how it moves here, like sort of like now they're all stacked on top of each other. And so I made this like really beautiful ordered table mapping with sort of like the head and then the 9 tails that we should have. Then I created an object which is the state, which stores the current and the previous position of whatever part of the rope we are in, and then we just loop that. And as you can see, yeah, so this is how it goes. Like now you can see how it beautifully follows this thing. And when I made this, I was like super satisfied with my solution until I realized that it's completely wrong. So now, as you can see, we are moving like a snake. So for example, in the diagonal move, like here, it's pretty evident how we're moving, but that's not how we're supposed to move. And let me show you. Oh, who arranged these wrongly? So this is how we're supposed to move. So you can see the head and then all the 4 here and then the 5th there. And then, okay, so never mind that this is 9, but that's, yeah, that's the 5th. And so yeah, as you can see, we are moving like a snake and not like a rope. And after hard work and realizing that I've done it wrong, I was completely devastated. So I started Googling like, okay, how should you like simulate this? And yeah, I found the solution. So let's comment that out. That was the previous one. So we cannot rely on the heuristic of like setting the like just the previous one to the next one, or like basically saying that 1 should have the previous position of head and 2 should have the previous position of 1. If we do that, we end up with a snake. So, but what we can do is we can do this fancy operation, and now when we do this instead, so now we're actually calculating where the next position should go with that, and now we're moving like we should be. So now we have like head is there, and then 1 goes underneath, and then we have until 4, and then the 5th is there. So now we're moving like a rope, and yeah, let's not go deep into how this works and why this works, but yeah, this is how we should do it. Okay, and I think I have set everything correctly now. So let's run it. It gives us 12,466. Submit, and that's not the right answer. Okay, yeah, and the reason is that you have to check that the tail is now, so if item equals 9, we only then update the score. Because now tail is defined as the last one. We don't want to have like the entire tail, which I previously thought, which was why we got like a crazy big number. So now we have a significantly smaller number, and yes, it's done. It's dealt with. Okay, so yeah, now it's basically 2 days since I started this. So what would be the learning from this time? We have gotten very familiar, I think, with sort of like creating these our own types. We have, and I think these actually make things a lot. How would you say? I can come to this task after 2 days, and it's still sort of like I understand what does what. I won't be able to break things easily, but it's still flexible enough. So I really like the way this was built, being able to just like do this mapping and have these different states. That was pretty easy to implement as well. All right, so hey, let's not sit here anymore. Let's get cracking on the next one.